folks, Mr. Norman here. We're going to go over domain and range of functions. So we're going to work some examples. The rest will be left for you to finish. So as you remember from last week, give me a sec. So as we know from previously, so it was purple and yellow. So we have domain, which is the set of all x values, and we have range, which is the set of all y values. So we're going to be writing this in two ways. We're going to write in interval notation and set build notation. Sorry, interval notation and an inequality. So inequalities have these symbols. Not equal to, greater than, less than, greater than equal to, and less than equal to. So we have interval notation with this parentheses or brackets, and an inequality, which is not equal to, greater than, less than, greater than, equal to, or less than or equal to. So we're going to look at our domain. To that, we're going to look at our function as it goes across the number line on the x-axis. So as we look to the left, it keeps going and going, and there's nothing that stops. So we keep going on the left. So we can say, if we're going to start this interval notation, this goes to negative infinity. So if we look to the right, it keeps going, keeps going, keeps going. As it goes down, it's going to go to the right. So it's going to go positive infinity. So to make that an interval notation, we use a parenthesis when it's not equal to. We can never equal or touch infinity, so we have a parenthesis on both sides. And to draw this as an inequality, we're just going to use our all real numbers, and this is our domain. So we go back up. We're going to do this for our range. So as we look at this thing's going to keep going up and up and up and up and up. Fired up. Fired up. All right, so we're going to keep going up and up and up, and we're not going to stop. So we're going to go infinity. As this goes down, it's going to go down, down, down to negative infinity. So for our range, our interval notation is negative infinity, comma infinity. And for our inequality, we'll write all real numbers. So we're going to do the same for this. If we're going to look at our domain, so as we're looking at our domain, if we look left and right, it only goes at one spot. This part is x. So all of these, every coordinate here is going to have the same x value. So we're going to equal -4. So for our interval notation, this thing got 4. It starts at 4 and it ends at 4. So this is our interval notation. Remember, the bracket means equal to. So our interval is from 4 to 4, and it's equal to it. Our equality is pretty straightforward. X equals 4. So next we're going to do our range. So as we look, we're going to keep going up and up and up and up and up, and it's never going to stop. So that's infinity. We're going to go down, down, down. So it's negative infinity. So this is our interval notation. So when we have negative infinity to positive infinity, our inequality is all real numbers. This one is similar to the previous one, it's just going left and right instead of up and down, I'll leave this for you. So now we're back to our, let me take a step back. This is a function. It passes the vertical line test. We can go across. We pass vertical line test. Notice when we pass the vertical line test, our domain was all real numbers. This fails a vertical line test because it is a vertical line. I'll give you a hint. This is a function. So that should give you a hint about what the domain is. So when you have a function, when in doubt, your domain is all real numbers. Is this a function? Yes. So what's our domain going to be? Probably all real numbers. So I'm going to start off with this, and then I'm going to check to see if it's true. Because like I said, if it's a function, our domain is normally all real numbers. So let's look. As we go to the left, this thing's going up, right? But it's going out in this direction. So as it goes up, it's slowly drifting left. It might take a while, but eventually it's going to go all the way over here. Same thing on the right. Eventually it's going to go all the way over here. What's back here? Negative infinity. It's over here, positive infinity. What does that mean? We're correct about the domain. Next one, the range. The range is a little more tricky. So we go up and up and up. These are going to keep going up, right? So if we look way up here, we're at positive infinity. As we go down, do we make it a negative infinity? No, we're stopped right here at 2. So to make our interval notation, notice that we equal that 2. That 2 was there. We equal, we have a bracket. We equal, we have a bracket. We equal, we have a bracket. So you have 2 comma, how high does it go? It never stops. We're going to have infinity. We do not equal infinity. So we have an open parenthesis. So how do we show this as an inequality? So y is our range, so that's the number we're looking at. And what do you know about our range? It is greater than or equal to 2. Bar means equal. Bar means equal. So this is absolute value. Is it a function? Yes, it's a function. It passes the vertical line test. So I'm going to go ahead and go with our prediction now. So our domain is probably going to be all real numbers. And so our domain is probably all real numbers. So let's check. So as we go to the left, this thing's going down, but it stays going left. Nothing stops it, so it's going to make it to negative infinity. As this thing goes to the right, it's going to keep going and never stops. It's going to make it to positive infinity. So now on to range. So this thing going to infinity? No, it starts at 0. And then it keeps going down, 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 down to negative infinity. Do we equal 0? Yes. Where does it stop at? Negative infinity. But wait a minute. Is 0 smaller than negative infinity? No, it's not. When we do this in interval notation, smaller number first. So that means we have negative infinity. It's smaller than 0. Negative numbers are smaller than 0. Bracket because it's equal to. So now we know we're going to have a y, and we know we're going to have a 0. But is y bigger than 0 or smaller than 0? It's smaller. The 0 is bigger, so the gator's going to eat the 0. But we're still equal to 0. So that's inequality. Notice when we're pointing down, it's less than. When it's pointing up, it's greater than. Up, down, down, up. I'll leave this one for you. I'll leave this one for you. Is this one a function? Definitely not. It fails a vertical line test all over the place. So our domain, we're not sure what it's going to be yet. We're actually going to have to look at it. What does it kind of look like? It kind of looks like a sideways parabola. A parabola is one of these. So we're going to start off with the interval notation. So this thing keeps going all the way to infinity. It does not stop. But what does it hit here? Hit 0. Does it equal 0? Yeah. So we're going to have 0, comma, infinity. And our inequality. So we have x, and is it bigger than 0 or smaller than 0? It's going to be bigger than 0. Now for our range. This thing, it's creeping up. It's creeping up. Eventually it's going to make it all the way up. It's going to creep, and eventually it's going to make it all the way down. So that means our inequality is negative infinity, comma infinity, which is the same as all real numbers. This one is for you. And this one's for you. So this one looks a little bit different. Does it pass a vertical line test? I know you're going to want to say no. I know this. I know this. But if you can draw a perfectly straight line, you'll see that you never actually cross this more than one time. So it passes the vertical line test, which means it's a function. And what do we say is normally the answer when it's a function for the domain? You guessed it. All real numbers. We're going to start at negative infinity, go all the way to the positive infinity. So let's look at it. This thing is going even slower than the quadratic. But this thing, as it goes, is slowly going to the left. Slowly going to go to the left, though. So what happens as we go to the left? We hit negative infinity. What happens as we go to the right, though? We hit positive infinity. Boom, boom, skadoosh. Now for the range. Let's see. Oh, this thing is going straight up, almost straight up. That's definitely infinity. That's definitely negative infinity. What do we have here again? All real numbers. I'll leave this one for you. So these are a little different. It's called a rational function. We don't need to quite know that yet. But look, in the middle, something funky's going on. It's going weird. It's going haywire. As this goes, it's slowly approaching this line. I'm going to tell you, when you see a shape like this, it never touches this. It never touches the thing that it's on the border of. We call this an asymptote, which means super close but never touches. Super close but never touches. Kind of like a Christian dance, a Bible study dance. You get super close, but you never touch. You gotta leave room for Jesus. So this has a domain. Well, it's a function. As we go across the vertical line test, it actually never touches the same part twice. But it looks weird, right? So let's look at this. When it looks like this, so look at this. This is obviously going to negative infinity. This is obviously going to positive infinity here. This is obviously a negative infinity here. But what happens if we go towards the middle? It dives down. It does not want to touch one number in particular. What's that number? 0. So as we look at it, we start at negative infinity and we go, start at negative infinity, and we go, then we almost touch 0, but it doesn't equal. What happens on this side? We start at 0 and we almost touch 0, we start there, but we don't actually get there and we go. So we're going to put in the middle. To connect it, we're going to have this U. And that union represents union. Union, like marriage, means to combine. So when you have a union in marriage, you know, two people's stuff becomes one person's stuff. So how do we do this as an inequality? So x is every number except 0, which means x does not equal 0. So for the range, this thing shoots almost straight up. This thing shoots almost straight down. Easy peasy, lemon squeezy. We got all real numbers. So I'm basically going to leave this exercise up to you. I just want to point out, you have to look closely to see where the asymptote is. What is it getting really close to but not touching? Same as this is also for you. Make sure you count the blocks. All right, Cal folks, that's the lesson for the day. Have a good one. Peace.